Hello everyone. Let's consider next point, expansion of sine n theta or cos n theta. Consider these notes first. By De Moivre's theorem, cos theta plus I sin theta raised to n is nothing but cos of n theta, this n attached to the angle. Now we are going to use the reverse of this statement, that is cos of n theta plus I sin theta is nothing but this n you can take on indice cos n theta plus I sin theta raised to n. This is by De Moivre's theorem. Okay, now this is, we know Pascal triangle. This is a short technique to expand any bracket, any power to the bracket. Now this is the Pascal triangle. This is 1. Now triangle edges of the triangles are only 1, and middle first second row is 1 2 1. Okay, next row will be the add these two numbers and write that number in between these two numbers below that next row. Okay, this is 2 plus 1 is 3, again 2 plus 1 is 3. Again next triangle must be increasing order, it must be goes on increasing in downward direction, therefore edges must be 1 and 1. Okay, next this is 1, this is 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is again 4, and last number is again edges is 1. And this is fifth row. Consider the fifth row. 4 plus 1 is 5, 6 plus 4 is 10, 6 plus 4 is again 10, 4 plus 1 is 5, and again last number is 1. You can go on adding all these numbers and make a Pascal triangle in this way. Okay, what is this triangle? This is the expansion quadratic formula we know. A plus b bracket square is a square plus 2ab plus b square. Next, a plus b cube is also we know, a cube plus 3a square b plus 3ab square plus b cube. Okay, now these are the this is the like onwards, a plus b raised to 4 and a plus b raised to 5 and a plus b raised to 6 we can expand by using Pascal triangle. For that, one common rule is there, that is a binomial expansion. What is that rule? Just go on decreasing, start with the indice as the a square here. Whatever the indice is there, you have to start from that in power to that first number a square, then go on decreasing the power of a, that is a square, here a raised to 0, and in the reverse manner go on increasing the power of b here b raised to 0, that is 1 is there, here b square. Okay, first and last power must be your indice, and this is the binomial expansion rule. It can be applicable to every power. Here also a cube, a square, a raised to 0, b raised to 0, b square, b cube. This is a cubic equation, cubic expansion. And this is raised to 4 is like this only, that is a raised to 4, start from a raised to 4, then a cube, a square, a raised to 0, and increase the power of b, that is b raised to 0, b square, b cube, b raised to 4. Okay, and so on. You can likewise expand the rest of the any term. Now what is the exactly problem while expanding these brackets? These coefficients, there is no any formula or synchronized formula for this coefficient, that is 1 2 1, this is 1 3 3 1, this is 1 4 6 4 1, and these numbers we can draw from this, we can take it from this Pascal triangle. Likewise, second row is a plus b bracket square, coefficient of a plus b bracket square expansion, that is 1 to 1, it can be taken from second row. In a plus b bracket cube, 1 3 3 1 can be taken from this third row. In a plus b raised to 4, 1 4 6 4 1, it can be taken from fourth row of this Pascal triangle. And a plus b raised to 5, how it is then? 1 5 10 10 5 1 can be taken from this fifth row, and so on. Like this is the short technique to expand any power positive integer should be there of any bracket. That bracket may be a plus b or a minus b. For minus sign, just put alternative plus minus sign. Like for example, a plus b. If a minus is there, what is the formula? All the terms are same. Instead of plus, middle term is minus. For this plus minus alternative plus minus. For this, if it is minus, this is first term will be plus always, and second term minus, third term plus, last term minus, and so on. Rest of the terms for minus sign also you can expand by keeping alternating sign plus minus. Okay, this is the second note. Now consider this is I square, we know minus 1. In some example, you may get I cube, I raised to 4, I raised to 5, I raised to 6, and so on. For that, you have to convert I power more than 2 into, split the power into 2. That is, for example, I cube can be converted into I square into I. What is I square value? Basic value is minus 1. That's why value of I cube is minus I. Likewise, I raised to 4 can be explicitly written in I square indices as I square. Okay. What is I square? Minus 1, that is plus 1. Therefore, value of I raised to 4 is plus 1. Likewise, I raised to 5. If you want to expand I raised to 5, what is I raised to 5? How can we expand this? I square, and I. 2 plus 2 plus 1, that is 5. What is I square? Into I square, minus 1 plus 1, value of I raised to 5 is I. Likewise, in some examples, you have to simplify like this. Okay. Now consider, for example, first example of this topic. We have to show that sine 5 theta value is this, and cos 5 theta value is this. Now consider these steps. That is the expansion of sine 5 theta. Here n value is 5. Again cos 5, that is n value is 5. Now consider the first step is De Moivre's theorem for 5. n is equal to this. We have to consider this De Moivre's theorem for n is equal to 5. Whatever number it is there in the example, you have to take that number. Okay. What is this? The De Moivre's theorem becomes then cos theta plus I sin theta raised to 5 is equal to cos 5 theta plus I sin 5 theta. Okay. Or directly you can take this step. Cos 5 theta plus I sin 5 theta is equal to cos theta plus I sin theta raised to 5. Okay. Now you have to expand this bracket using this note. What is the expansion? A, this is your A cos theta, this is your B, I sin theta is B, A plus B bracket raised to 5. Using this formula, you have to expand this bracket. What is the first step? First number, this is A raised to 5. First number raised to 5. That's why it is cos raised to 5. Second is 5 A raised to 4B. 5, this A raised to 4 into this B. Plus third term is 10 A cube B square. 10 cos cube this B square. Plus again next 10 A square B cube. Plus 5 A B raised to 4. And last term is B raised to 5, that is B, this is I sin theta raised to 5. This is the expansion of this bracket. Now next step, wherever I term is there, just simplify that. This is cos raised to 5 is there, then take I first, this 5I cos raised to 4 sin, this is as it is. Here I square is there and sin square. What is I square? Minus 1. That's why this term becomes minus 10 cos cube sin square. Next term I cube is there. What is I cube? Again I square into I minus I. Therefore put I cube value is minus I. 10 minus I cos square sin cube. Okay. This is I raised to 4 sin raised to 4. What is I raised to 4? Is I square this plus 1. Therefore this term becomes 5 cos theta plus 1 I raised to 4, that is sin raised to 4 theta. And last term is I sin theta raised to 5. What is sin raised to 5 as it is, and I raised to 5 is this I. Therefore this becomes I sine raised to 5 theta. In this step, first step you have to expand this as it is by keeping the bracket to the second term, and in the third term you have to expand this I term using this note. Okay, now next what we have to do, just underline the non-I term, or you can underline the I term also. Okay, these are the I term. I am underlying I term here. This is I term, this is I term, where term is consisting I only, and this is the term not consisting I, therefore we are not underlying this. Now this is I term, this is I term, this is I term. Make sure that that terms are on alternate manner only. Okay, now take common I from these all three terms, and rest of the terms are non-I, these are real parts. Okay, these are the real parts, and these I terms are the imaginary parts. These terms keeps as it is, and plus take common I from these three terms, we get I common, and rest of the three terms as it is. Now what is this step becomes now? 5 cos 5 theta plus I sine 5 theta becomes, sorry, cos 5 theta plus I sine 5 theta is equal to this total term. This is one complex number, and this is also other complex number. And when two complex numbers are equal, when their corresponding real and imaginary parts must be equal. What is its real? This complex number, its real part is cos 5 theta. While here, this total term, 1, 2, 3 term, is a real part of this side, where sine 5 theta is imaginary part of this side, and where I terms here, coefficient of I is the imaginary part. Therefore, comparing real and imaginary part on both sides, what we get, cos 5 theta is nothing but this term. Okay, and sine 5 theta is nothing but this bracket. Okay, now consider the first only, but we have to prove both. Consider first cos 5 theta is equal to this bracket as it is. Now what we have to prove? Cos 5 theta is in terms of cos only. There is no any sine term here. But what we get here by our theory, some cos terms are there, some sine terms are also there. There are two sine terms. Then ultimately what we have to do? We have to convert these sine terms into cos terms using one formula we know, that is sine square plus cos square is 1. That is sine square theta plus cos square theta is equal to 1. Therefore sine square theta becomes 1 minus cos square theta. Wherever sine square is there, we have to put 1 minus cos square. Wherever sine raised to higher powers are there, we have to put higher powers of this. Okay, in this case, cos raised to 5 as it is, this term 10 cos cube as it is, and sine square becomes 1 minus cos square. And here these two terms as it is, sine raised to 4 becomes sine square square. That is sine square, that is 1 minus cos square, its square. Now in this step, we totally exclude the sine terms, convert those sine into totally cos terms. Just we have to solve this, and we have to reach this statement. Okay, this term as it is, cos cube as it is, multiply these two in the bracket, we get minus 10 cos cube plus minus minus plus 10 cos raised to 5 plus, now expand this square, a square, that is 1 minus 2ab, that is 2 cos square, plus b square, that is cos raised to 4. Now next step, we have to multiply these two brackets. These two are same. 5 cos minus 5 to the 10 cos raised to cube plus 5 cos raised to 5. Now in this step, there are some common terms are there. Cos raised to 5, cos raised to 5, cos raised to 5. Total becomes 16 cos raised to 5. And this one is 10 cos cube. Here also minus 10 cos cube. These two gets add, minus 20 cos cube. And this is single term 5 cos. This is what we have to prove. Okay, now consider the sine 5 theta also. You can take sine 5 theta, which is equal to this imaginary unit except I. Okay, exclude this I. This only bracket is a sine phi theta. Therefore this sine phi theta is this bracket by our earlier step. Then what we have to prove? Sine theta phi theta consists of only sine term. There is no only cos term. Now in this case what we have to do? Just we have to convert this cos terms. This one is cos term and this is also this is second cos term into sine terms as 1 minus sine square, its square bracket raised to 4 is there, and here cos square is 1 minus sine square. Similar in what we have done in cos phi theta. Okay. Now expand this square. A square minus 2ab plus b square, that is sine raised to 4. And next step, just multiply these two terms and rest of the term as it is. Now again multiply these two terms, 5 sine theta minus 5 to the 10 sine raised to cube plus sine 5 into sine raised to 5. The rest of the terms as it is. Here also some terms are common. Add these two terms and minus 10 sine cube. This is also same. This is also we get add. Addition of these two gets minus 20 sine cube, and here total term are 16 sine raised to 5. This is only single term. This is what we have to prove. Okay. Now consider next example. We have to show that tan 7 theta is equal to this unit. Okay. The theory is of only expansion of sine and cos. There is only expansion. We can expand by this theory only sine and cos terms. We cannot expand by this theory tan terms. But we know what is tan. Tan theta. Tan theta is sine theta upon cos theta. Therefore, in this particular example, if we want to find tan 7 theta, we have to find sine 7 theta and cos 7 theta by our usual method. Okay, for that consider 7, take n is equal to 7 in De Moivre's theorem. We get cos theta plus I sin theta raised to 7 is equal to cos 7 theta plus I sin 7 theta. Therefore, this term becomes this. Expand this by using the Pascal triangle as same as in earlier example. This next step is again I terms simplification, and from third step we have to collect the real part one side, and from imaginary part take I common, and rest of the terms are as it is. Again comparing both side by this is cos 7 theta plus I sin 7 theta. Cos 7 theta becomes this total term, and sin 7 theta becomes, exclude this I, this bracket is sin 7 theta. Okay, by this theory we get cos 7 theta and sin 7 theta. Now consider tan 7 theta. What do we have to prove here? Okay, tan 7 theta is sin upon cos. This term divided by this cos term. Okay, this is what we get. Now what we have to prove? Just observe that there is no any sin or cos term here. There is only tan terms are there, and here what we get, all terms are cos and sin. Okay, if you observe numerator and denominator, if you want to convert this into tan, what we have to do, sin upon cos term should be there. Okay, like for example here, if you want to convert this sin raised to 7 theta into tan, what we have to do, just divide this numerator by cos raised to 7 theta. The rest of the terms can adjust automatically. Okay, if we divide the numerator by cos raised to 7, ultimately we have to divide this denominator also by cos raised to 7. Okay, what we have to get then? Let us see. Multiply and divide by above. Now multiply and divide by above numerator and denominator by cos raised to 7. What we get here? This is if you divide this number by cos raised to 7, cos raised to 6 gets cancelled. One cos is remaining, that is sin upon cos becomes 10. Minus this 35 as it is. Again cos raised to 7, if you divide by that, 1 cos raised to 4 gets cancelled. Remaining cos cube combined with the sin cube, we get tan cube. Plus 21 as it is. Again cos raised to 7, if you divide by that, cos raised to square gets cancelled, cos raised to 5 remaining. Sin raised to 5 upon cos raised to 5 becomes tan raised to 5. And last minus sin raised to 7 upon cos raised to 7 is tan raised to 7. Similarly, in the denominator, cos raised to 7, if you divide by cos raised to 7, here we get 1. Minus, if you divide this by cos raised to 7, we get cos raised to 5 gets cancelled, sin square upon cos square is tan square. Plus 35, again cos raised to 7, cos cube gets cancelled, sin raised to 4 upon cos raised to 4 is tan raised to 4. Minus 7, again cos raised to 7, 1 cos cube, cos gets cancelled, sin raised to 6 upon cos raised to 6 becomes tan raised to 6. Okay, which is our required answer. Okay, this is your homework. You have to prove tan 5 theta is this. Solve as above example, you get the answer. Now consider next example. Similar way you can solve this example also. Let us have the glance on this answer. We have to prove that sin 6 theta upon sin 2 theta is equal to this. By above method, just solve at your own. By above method, we get sin 6 theta. Consider n value, put n value 6 in the De Moivre's theorem and expand all those things like in the earlier example. You get sin 6 theta is equal to this total term. And what we have to prove? Sin 6 theta divide above by sin 2 theta. We get this term divided by this sin 2 theta becomes, this is the formula we know, sin 2 theta is 2 sin theta cos theta. Okay, this is 2 sin theta cos theta. Now separate, divide this to numerator by this denominator. What we get? 2 3 is 6, cos 1 cos gets cancelled, cos raised to 4, sin gets cancelled, minus 2 2 gets cancelled, 1 sin square remain and cos 1 cos remain. Sin square is remain and 1 cos is remain. Okay. Plus 6, 2 3 is 6, 2 3 is 6, this is 3, sin raised to 4 and cos gets cancelled. Okay. Here cube is there, that's why 1 cos gets cancelled, cos square is remaining. Now this is what we get, our answer. What we have to prove is this. It doesn't contain any sin term, while we get the one sin term here. Two terms are sin. Okay, two terms are of sin square and sin raised to 4. Again, by using formula cos square plus sin square is equal to 1, put the value sin square is 1 minus cos square theta, and sin raised to 4, put value sin square square or sin square into sin square, that is 1 minus cos square its square. Again expand this bracket, a minus b bracket square, and this multiply throughout the terms with the brackets. Some terms are common, add these all terms. Okay, this is also same as this term. Minus 6 minus 10 is minus 16. The rest of the 3 as it is. This is what we have to prove. Okay. Similar way, try this example. Express sin 7 theta upon sin theta in the power of sin theta. What you have to do? Expand like this, or like an earlier example, sin 7 theta. Already we have here in earlier example. This is what we have to what we have already solved it in tan 7 theta. Sin 7 theta is this. Follow as it is, the steps as it is, and 7 theta divided by sin theta, and ultimately what is the question? Express this in the powers of sine only. The answer should not should not contain only cos term. It have to the answer should be, this is B, the answer should be in the power of sine, not cos. Okay, for if any answer if answer comes in cos terms, you have to convert it into sine by using this formula only, cos square plus sine square is equal to 1. Okay, now this is the expansion of sine theta and sine n theta and cos n theta. Now consider the next uh, step or next point, expansion of sine raised to. In earlier we have just seen sine in multiple angles n theta. Here we have to expand sine raised to n theta or cos raised to n theta. Okay, now consider these points. Let x is equal to cos theta. This will be your beginning of the answer, first step of our answer. Let x is equal to cos theta plus I sin theta. What is 1 by x? Just replace plus by minus sign. It's a complex number. Okay, therefore x raised to n becomes this bracket raised to n. Again De Moivre's theorem, it becomes cos n theta plus I sin n theta. This is x raised to n. What is 1 upon x raised to n? Just replace plus by minus sign. These four terms are there. Depending on the number n, just replace accordingly the example, the number containing in the example. Okay, now add these two numbers. What we get, x plus 1 by x becomes I term gets cancelled, cos 2 cos theta. And if we subtract this number, cos term gets cancelled, x minus 1 upon x becomes 2I sin theta. I term gets added, 2I sin theta. Similarly, add these two terms, x raised to n plus 1 upon x raised to n becomes I sin n theta gets cancelled, cos n theta becomes 2 times 2 cos n theta. And similarly, subtract these two, what we get, x raised to n minus 1 upon x raised to n becomes cos term gets cancelled and I sin n theta terms becomes 2 times 2I sin n theta. This is total 4 steps in the examples. Okay, now consider first example of this point. Prove that sin raised to 5 theta is equal to 1 upon 16 of this total term. We have to find sin raised to 5 theta. In earlier example it is different. In earlier point it is sin 5 theta. This is the point of expansion of sin n theta, multiple angle, where it is the power of the trigonometry, power of sine and cos, sin raised to 5 theta. This theory is different. Okay, now consider here n, put n value is 5 and output n is equal to 5 in all those above expressions. What we get, consider x is equal to cos theta plus I sin theta. 1 by x becomes cos theta minus I sin theta. Subtracting, if you want to prove sine example, then consider this term, x minus 1 upon x. We don't need to consider this term, okay, when sine example is there. Now consider here we have to expand sine raised to 5 theta, therefore consider this term, x minus 1 upon x is equal to 2I sin theta, where sine term is there, not cos. Okay, now put n value is 5 and expand these two term both side by 5. Take indice both on both side by 5. What we get, 2I sin theta raised to 5 is equal to x minus 1 upon x raised to 5. Okay, now we have to expand this bracket raised to 5 as by using Pascal triangle only, that is a plus b raised to 5. Okay, what is a here, x, and what is b here, 1 by x, but middle sign is minus, therefore you have to put alternating plus minus sign. Okay, therefore plus first term is x raised to 5, second term is minus, that number is 5 in the Pascal triangle, then x raised to 4, just reduce power of x, 5, 4, 3, 2 and 1 here. Okay, and 1 and 0, and increase the power of 1 by x. Here 1 by x power is 0, 1 by x raised to 1, 2, 3, 4 and last 5. This is minus sign 5. and these number we can take it from Pascal triangle 1 5 10 10 5 1. In this way we expand this bracket a minus b raised to 5 using a minus b raised to 5. Now simplify this term, just cancel these powers of x in the numerator and denominator. We get this, here x gets cancelled, x cube remaining, and rest of the term gets simplified as it is. Okay, now in this step what we have to do, x raised to 5 and reverse of x raised to 5, we have to combine those terms, like in first step and last step combine this. Then second step and second last step contains x cube terms, and 5 is common, take outside. And if x raised to cube, x cube is first term, take minus outside, because you have to for sign term we take middle sign minus, therefore for minus sign you have to take minus sign outside. Minus 5 take common from these two terms, but we get x cube is plus and this term becomes minus. Okay, because minus sign we take it outside. And last these two terms, 10 is only common and this is the minus only, this contains already minus, therefore plus 10 is common, rest of the term is x minus 1 by x. Okay, first last, second last, third last, we have to combine like this only, and whatever the number is common, take it outside. Okay, now what it comes out, x raised to 5 minus 1 upon x raised to 5 by using this formula, x raised to n plus 1 upon x raised to n value is 5 here, sorry, not here, minus sign is there. What is this number then? Using this formula, 2i sine 5 theta here. Again here x value is 3. The answer for this bracket is 2i sine 3 theta plus this bracket is x raised to 1, n value is 1, therefore value of this is 2i sine theta only. Okay, we have to use this result for this 3 bracket. What we get then? Now LHS sign is, LHS side is 2i sine raised to 5 theta becomes 2 raised to 5, I raised to 5. What is I raised to 5? I square into I, which is ultimately I. Okay, and sine raised to 5 theta. Okay, now 2i, that is 2, first term is 2i 5 sine 5 theta, it is 5 as it is, this 5 as it is minus 5, and this becomes 2i sine 3 theta and plus 10 into 2i sine theta. Okay, now in each term, this is the only this in last in every example in last step 2i terms are common. Okay, just divide by 2i throughout. What we get? 2 gets cancelled, 2 raised to 4, I gets cancelled, sine raised to 5 as it is. Here 2i gets cancelled, rest of the term as it is. Okay, this is 2 raised to 4, sine raised to 5 theta value is this. And we have to prove, we have to find sine raised to 5. Our question is sine raised to 5 theta becomes this. Now we have to prove this. Therefore, take 2 raised to 4, that is 2 into 2 into 2 into 2, that is 16. On that side it becomes it comes to denominator and these terms as it is. This is what we have to prove. Okay, now consider cos example.